Alright, this is the second video in factoring. The first video was taking the GCF. This is going to be about the difference of squares and the sum of squares, or you might say the subtraction and the addition of squares. Notice here is the subtraction symbol. Sorry about that. And then here is the addition symbol. And what are we talking about by being of squares? If you were to take 4x squared, you could unmultiply it to be 4x, not 4, 2 rather, 2x multiplied to 2x, and 121 would be 11y multiplied to 11y. Another way that you could try this is to see is the square root of 4 produces 2, which gives us our 2's. The square root of 121 is equal to 11. So, I wanted to bring over an example of something that we did multiply together, and I want to, so if I were to take the expression 4x minus 5, multiply that to 4x plus 5, I would get 4x squared plus 20x minus 20x minus 25. Notice what's happening right here in the center. This section here is going to eliminate itself, and so I will end up with simply a product of 4x squared minus 25. Reminder again, these are factors, things that are multiplied together. This section here is the product. We are used to working our way from factors to product. This entire section is asking us to take the pathway backward, and that's what we're working on. So, let's look at this for a moment. Let's work with this particular problem here. We've already understood that 4x squared is going to be 2x multiplied to 2x. We see that it's subtraction, and there's 11y multiplied to 11y. Notice you have identical entities in the front and in the back. The way that this is written, and again I'm bringing over my example here, identical phrases with simply addition or subtraction in the middle produces a situation where the middle term cancels out. So I'm going to use 2x in the front of this, 2x in the front of the second binomial. I will use addition and subtraction, and then to finish off the phrase I will use 11y in the back and 11y in the back of this. Now, let me look inside and make sure that there are no more common terms, and there's nothing else to do, so I am finished here. Alright? Looking at something different here for a moment. If I were to talk about the addition of squares, one person might think that if you take two binomials that have the same sign and multiply them out, that you would be able to get this entity here. Watch. I just did this after I paused the video. I took, as opposed to the difference of squares where one sign is the same, and one sign is plus, the other is minus, I made the two signs equal to each other. I made this, both have plus. So it's 3x plus 2, 3x plus 2. The middle term here does not cancel out, so I end up with a trinomial. Getting to this expression here, we have two parts, and they've been added. You cannot multiply in order to get it. So in this sense, what I am saying is this cannot be factored. cannot be factored. This is really important because they're going to try to get you to do so. All right, let's move on. Reminder, one of the first special patterns we have is going to be the difference of squares and the sum of squares. Only can you factor the difference of squares. This here, please don't touch it. All right? In the spirit of Halloween coming up, don't touch. All right, let's look at this. This one here we already have done. We understand what it is. This one here, we have done it. So, as a reminder for this first problem, we would end up with, we know that this is 2x multiplied to 2x, 11y multiplied to 11y. So then I understand that it was going to be 2x plus 11y and 2x minus 11y in the back here, and we are finished. We already did this problem, just completed it again. Not sure why. This problem here we did on the front page. Notice this problem here, example number 4. I'm purposely skipping example number 2 for a moment. This one here is a sum of squares. What we do need to check for, we must check, we haven't done this yet, we must check for a GCF. And so far, none of these problems have had a GCF. What I want to do is to skip to the next page. I want to return to this problem in a moment. So we're going to come back. Factor completely. So again, please remember, the first job that we have is to check for GCF before we can even try to do a difference of squares. And that's good because the square root of 8 doesn't produce a whole number, neither does the square root of 50. These are not perfect squares. So, if I were to divide each of these, they both have an x, so I can divide by the x. And if I were to divide by 2, I would produce, here is my GCF, as we remember, record the GCF out front, and I will be left with 4x squared minus 25. Now this is as far as we took it in the last video, but notice what we have on the inside here. This interior part is a difference of squares, a subtraction problem of squares. This is going to be 2x multiplied to 2x and 5 multiplied to 5. This will come apart into two different binomials. We'll have 2x minus the 5. I'm going to put plus the 5, and then 2x minus the 5. I should not box this up and say complete or done because I have to remember to bring down this GCF of 2x. Now, I can write finished. We can check this in the calculator. Here I am with my calculator. 8x cubed, so to the power of 3, minus 50x. What I'm going to do is to take, that's my first part, that's where I start, so where I finish is going to be my result, and I'm going to type exactly what I created, 2x, here, open a parenthesis, 2x plus 5, close a parenthesis, open a new one, 2x minus 5. As we did in the first video, we're going to look at the table as opposed to the graph. It's just a little quicker. Second table, my y1, oops, I've typed something incorrect. Let me go back. That was a good indication that I've typed something incorrectly or my math problem is wrong. Let me go back and make sure. I think I might have missed the subtraction in this second binomial. And this is a good lesson to look at just because, yes, you see how I should have typed 2x subtract 5 and I ended up missing? Go in, type subtract 5, close the parentheses one last time. Now I should have equivalent answers because I've made two equivalent expressions. And you see y1 is always in match with y2, no matter what values we are looking at. So we can use the calculator or we can multiply this out by hand. We know we've done it correctly. Number 6. Again, if I were to try to do the square root of 32, I think we understand that it's not going to give me, it's not a perfect square. So that's an indication that I need to look for a GCF first. I remind us all that we need to look for the GCF first no matter what. It makes life a lot easier. If I were to divide each of these by 2, divide by 2, my GCF can be a 2 on the outside. What I've made on the inside would be 9x squared minus 16. This is easily recognized as 3 times 3 and 4 times 4. So I have 3x multiplied to 3x. That's what my dot means. And then I have 4 multiplied to 4. I see that these are perfect squares, and I've got a subtraction problem built out of them. So this will come apart into two expressions. 3x plus 4, and 3x minus 4. If I were to box this up and say finished, I would be incorrect because I did not bring down the GCF. Now I am finished. I see here a sum problem, an addition problem, but I do not see a sum of squares. What I should do first is GCF, look for the GCF, and by the way, just a reminder, the GCF is here if you're looking for it, and this is the GCF here. It's always the first part. Divide again these. It's the same exact problem as problem number 5, just we switched it to plus. I know I can do a GCF of 2x, which will produce 2x multiplied to 4x squared plus 25. But here we must stop because we already identified the fact that we cannot factor this interior part. This here is a sum of squares. So now we are finished here. Similarly, all I did for problem 8 is to take problem 6 and switch the sign, so we know the GCF is going to be a number 2. So the GCF recorded out front on the inside will be 9x squared minus 16. Plus 16. Don't make that mistake, please. Again, the inside here, this is a sum, so we should stop. I see the sum of squares, we should stop. I am finished here. All right. That's pretty much it, except there is one problem that I want to go back. Number 2. This one here, because I have an even power and I do have a number that is square rootable. So if I'm not sure, I can take the square root of 256, and what I will produce is 16. So I understand that this is 16. I understand that this is 16 times 16. I see this even power, which might be confusing to some, but if I multiply x to the 4th multiplied to x to the 4th, I see that it actually is a perfect square. Any even power should be a perfect square. For example, x to the 6th is really x cubed multiplied to x cubed. X to the 10th is really, could be x to the 5th multiplied to x to the 5th, because what we are really doing is simply adding up the exponents. And again, x to the 20th would be x10 multiplied to x10. So this is an even power. I understand it is a perfect square. I can then write, and I'm going to scoot over here for a moment, x to the 4th plus 16 and x to the 4th minus, that looks like a 9, x to the 4th minus 16. I'm not done yet. Always what I should do is check inside here, looking in here. All right, I see it's perfect square, but it's the sum of squares. It's the sum, so I can't continue. However, on the back end, I see a difference of squares. This needs to continue and break apart again. So this back binomial actually comes apart further. So what I'm going to do, this is going to be 2 multiplied to 2. I mean to say x squared multiplied to x squared is what I meant to write. X squared multiplied to x squared. This is going to be 4 multiplied to 4. This will come apart into 2 binomials. X squared plus 4, x squared minus 4. This binomial is kind of out of the game. He opened up and created 2 others. So now I have 3. I have 3 binomials that I'm working with. I can bring down this x squared plus, keep writing square when I meant to write 4, 16. I have 3 terms now. I'm sorry, 3 factors now. Again, I would think I'm done, except I want to look carefully on the inside. We've looked here. This is the sum. This here is a difference of squares. So I can again open this up one last time. This, of course, will be 2 multiplied to 2 and x multiplied to x. So this, I'll just switch color actually. This subtraction will produce its own 2 binomials, x plus 2, x minus 2. Again, this part has opened up or is no longer part of it any longer. It opened up and gave us 2 others, and I am left with 4 binomials this time. X to the 4th plus 16. This would be the complete and final factorization. It would be a good idea to take this in the calculator and check, does these 4 binomials actually multiply and give us our original problem at the beginning. Practice these. Thank you.